What is compost? Compost is a widely accepted organic fertilizer throughout the world. It is being produced using a wide variety of source materials at household to commercial scale. With the increased population and changes in food consumption pattern, the amount of organic waste generation has increased. Many governments promote composting as a process that helps them to reduce the volume of organic waste and recycle nutrients back to croplands. Compost in Sri Lanka. However, large-scale production of compost using traditional methods is generally limited to government agricultural farms and training centers. Domestic-level compost production also takes place, and it usually fulfills part of the requirement of their home gardens. To meet the country's compost requirement, there is a need for more large-scale compost production facilities in the country. Major difficulties in medium and large-scale compost manufacturing. Moisture and temperature control are key challenges in both large and small-scale compost manufacturing in Sri Lanka. Most large-scale compost producers operate their windrow composting processes in open spaces due to a lack of resources. The amount of moisture during composting process can't really be controlled due to the tropical weather conditions in the country. As a result, final compost product quality is difficult to maintain at standard levels. Also, the decomposing process takes a long time, which slows the procedure. Because of the wet conditions, a significant percentage of mature compost got rejected during the sieving process. Proposed solution. In this experiment, we are going to sustainably utilize the residual heat generated from the incineration process to optimize compost production, managing the moisture content of mature compost before the sieving stages. In that case, we check the possibility of controlling the moisture level and the temperature in compost by using the hot air drying methodology. In there, we test the feasibility of manufacturing thermophilic compost by varying the moisture and temperature in compost. Also, try to improve the yield by minimizing the wastage which are not sieved properly due to the wet conditions. Our innovative project, Sisili Hanaro Encare, is Sri Lanka's largest clinical waste incinerator facility. There are nearly 12 to 15 tons of clinical waste is treated in the scientific incineration process daily. As a byproduct of that incineration process, nearly 2,000 kilograms of steam is produced in 1 hour. Using that byproduct steam as a heat source, hot air is produced, which is then used to maintain the temperature and manage moisture to produce hygienic compost at higher production rate. This integrated approach will improve the sustainability of both projects. Main steps in temperature and moisture management. Process 1. Produce hot air using steam using a heat exchanger. To generate the hot air stream in this project, we use steam, an unused byproduct of Sisili Hanaro Encare's incineration process. The hot air stream will be used to maintain the temperature of partially processed organic matter. 2. Blow that hot air and inject that through the mature compost using a blower and damper system. The airflow rate can be controlled by adjusting the opening of the damper. The heated air is then directed to a drying bed, which is used to maintain temperature and moisture content of the partially processed organic matter. Current stage of development. This project is now at the prototype testing stages. After the initial literary surveying, basic calculations did under the expertise supervision. After developing the computer model, the main objects, which are heat exchanger, drying bed and the blower connection, has now complete in the testing kit. The testing part is to conduct under the supervisor's guidance. In the next phases we are going to improve the process by following developments. In municipal waste there are nearly 8 to 10% amount of wood is collected which take long time to decompose. Also there are nearly 6 to 12% amount of wastage polythene and plastic which can't recycle or reuse. In the next phase, we intend to use the unused trash and woods which unable to decompose in short times as fuel to power a furnace and generate hot air as a source of energy. That is a material recycling method and sustainable energy source to a commercial level plant. Also make crop-specific compost by maintaining a precise level of moisture and temperature and adding the required nutrition and minerals as a value-added process. Then develop this methodology up to a continuous type operation facility.